Cool.
Orange should be good.
All right, let's see. If I click that, and then I go like this, and then I do that, and then I hopefully don't make the same mistake
I can
as
see both
last
your
time.
screens.
You can see both of them?
Yes, I can see the one.
Well, both windows, not so
Both
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 windows.
windows, I
windows.
should
Okay,
say.
okay. I
Yeah,
was
yeah,
like,
yeah, yeah. Sorry.
got it, for sure.
Yeah, I don't want to. I don't want to know what you got on the other screen, man.
Well, mostly it's monitors and all that other junk, so
All right,
nothing too exciting.
all right.
So yeah, I guess
Wait,
the
wait. Should I start the recording? Are you going now?
sure. Well, I mean, yeah, unless we got anything else we want to check in about before we turn
Okay.
the cameras on.
I,
Yeah,
I'm gonna start the recording then.
sure.
Recording in progress.
Indeed. Yeah, so last week we were going through we were going through the repo a little bit, and then also this sort of other paper on the side. The repo specifically being Entropix, which is in one of these tabs here, and I really wish I could make this little gray thing go away. Can I make it go away? Hide video panel? No, I don't think I. Okay, but now it's behaving very. Oh, I can just move it around. Okay, just move it over there. That'll work. Okay, one moment here. Show video panel. Okay, we're good. So I need to find if I have the actual repo. Oh, I do. It's over here. So um, basically the paper is kind of all about chain of thought decoding, and then the repo is a similar kind of principle but different, but it is more on the sampling step, but they're both kind of looking for like conditions during inference to sort of insert some sort of optimization. Um, I haven't actually read much more of the paper than I did last week, but I have found a couple of interesting, I guess, additions since then, and then I managed to stumble my way into a group chat with some of the core developers of Entropix, and that is how I learned that actually currently the latest update is it would not compile with the JAX JIT, or it was either Torch or JAX that would not JIT, and so I think the XJ is having to rewrite it all from scratch. So as one does, but the some of the cool stuff that I managed to find with relation to it is I made a few like mermaid charts just to as like kind of a guide, because I know last week we were kind of looking for what was doing what, so I was thought that this might be a little bit more helpful. And then the particular thing. Oh, I really hope I'm not out of TPU. But the particular thing that is interesting is there is this little collab notebook, which has a 360M model. It's the small LM, and then it's kind of showing you the entropy and varentropy as it generates, and then where it sort of like kicks off one of those sort of form that we saw last time. So I thought that was pretty interesting. And then I have a couple of resources of oh yeah, and then one of the folks over there has been uh, well, two of them. The I'm trying to think of what the thing is, but there's another branch. I don't remember exactly what the difference is off the top of my head, but I know there is like a significant divergence between main and then frog. So we can probably look around through that as well. Um, and then also one of the other folks in the group chat is, I believe somebody was playing with tuning the thresholds, and I think they cut actually a few of the parameters that were previously getting changed that aren't anymore, and they were finding that they were not. They had like similar performance, although I think we're still working on benchmarks too. Um, but yeah, I guess those are kind of the main updates, and then obviously I've found a few more papers, but I think kind of the sentiment that we landed on last week with regard to the paper was that the kind of the metric that they were using with GSM 8K, using that as the scoring mechanism, at least from the other folks that I spoke with, it seemed like kind of our thought that like you kind of need a GSM 8K to do that kind of measurement, or you need something with this very clearly defined right answer, and that seemed to continue to hold true. But we could go. I suppose my thought being we could finish up going through the paper if that is still of interest to kind of dig into that a little bit more, and then that's I guess a general overview of the new stuff that I have found for the repo itself. So maybe we can go through some of the different kinds of optimizations that folks have made thus far. But yeah, if anybody's got questions, go for it.
So what's the summary? What's the one paragraph summary of the paper, the chain of thought reasoning paper?
So the chain of thought decoding is the idea being, if we can chain of thought during prompting, can we do that without having to prompt them? If we do, is there something we can do during the training, or in this case, the decoding step, to get that same performance increase that chain of thoughts provides, either by actually getting it to do chain of thought during decoding, which is what this one does, or performing some other optimization that allows for extra reasoning without having to modify the prompt. But yeah, go ahead.
Yeah. So I was going to say, yeah. So what I was getting, what I walked away with was this, not intuition, but this understanding that if you think of the branches that you probable, but may end up at a different point and possibly a much better point. Is that does that match up?
Sorry, my connection dropped, so I only heard the last bit of that. But yeah, the thought being that for any given path, there's going to be there will be some of the potential decoding steps that I think they have a confidence metric that they sort of approximate in here, and then they use, I think, the delta of that of the lowest to the highest of those values to choose.
Yeah, so kind of it aligns with the other repository where it's kind of reflects the entropy of the prediction, right?
Essentially, yeah. Actually, I need to step away for just like 2 minutes. I'll be right back. But feel free to have any other thoughts, I suppose.
So Roger, I'll jump in. So if you're not, by the way, people don't always do greedy decoding, but when you're doing analytical type LLM work, right, you tend to do that because you don't want variety, you want like the best answer, right? So like, they don't necessarily use greedy for everything, like if you're going to ask it to write a poem or something. But But so what you said is right, that like here's an alternative to greedy, but I think that you run into two high level problems. Okay. So one is, how are you going to reduce the search space? Because if you decide you want to go 6 tokens out and you're going to choose 10 options for the first token, and for each of those you're going to choose 10 options for the second token, and for each of those you're going to choose, right? Then
Right,
you're going
right.
to wind up with 10 to the sixth, you're going to wind up with like, a million different branches you have to all
Yep.
inference and calculate, whatever, right? So then we can talk about different search algorithms, beam search, blah, 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 whatever, right? Then the second problem you have, other than reducing the number of things you're going to search, is how are you going to score them? How are you going to pick them,
Yep.
right? So, like traditional beam search would say, I'm just going to look at the I don't know if cumulative is quite the right way to say it, but the cumulative probability of all 6 tokens,
Yep.
right? So you might have one path that starts out higher with a 30% token and then goes bump, 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 bump. But this other one, even though it starts with a lower, it starts with a 10, suddenly it really finds its footing and it gets a 90, 90, 90, 90 on some tokens. And then all told, the cumulative probability ends up being higher than that, right?
Right.
So I think the two things that they covered in this paper is, one, they said the way we're going to limit the search is we'll take 10 options for the first token, and then everywhere from then on we'll only take one option for each token. So that's relatively cheap,
Right.
right? It's exactly 10 times the cost of just doing straight inference ish,
Yeah. Yeah. Yeah.
And so then they came up with this metric that I think we didn't quite completely understand, but there was some way that they were saying, when you see this super high confident, uh, um, in the case of like grade school math, when you see this like super high confident number relative to, and the relative to is the part that I at least didn't quite get my head around
Mhm.
exactly what they were. But when you see that, then that's the one of the 10 that you pick,
Right.
right? So you don't really care if the cumulative probability of the thes and the other words in the sentence completion are the highest. You just care about some special property of when they see the answer tokens, you
Right.
know. So this Sally has
Yeah.
213 apples. You want that 213 to be differentiated.
Right. So they had some heuristic for scoring that identified. I
Yeah.
think they had a simple rule like the last number or something like that, um, that identified the important part, and then just looked at the confidence or
Right.
entropy
So in
equivalent.
terms of that technique, then we can say we'll evaluate it on 2 levels. Super specifically applying their exact technique, it kind of seems to be more limited towards where you have a question that has a specific numeric answer or ABCD multiple choice answer, where you can really hone in on which tokens represent its quote unquote answer versus just the thes and the other words and the becauses and the, you know,
Mhm.
and the intermediate thinking words, right? That's not what we're looking for. So
Right.
so that's the part where I think it was like, it's hard to see how you would like really extend this. But
Yeah,
then
although
more,
I really like the idea that there's actually there are these other sequences that we're not exploring because of our current, exploration rules. We don't see these other sequences, and I think one other thing that, if I'm understood correctly, that they also identified that when they found something that had a high confidence in a number, and then they look back, they would often see chain of thought types of words leading up to that high confidence answer.
yeah.
And
That's my
they were
understanding as well.
specifically looking for chain of thought, but they found it when they had high confidence. Does that align with what you thought?
Yeah, and to me it seems kind of intuitive, because like if you're going to take more words before you spit out the number, what else are you going to say other than some sort of chain of thought, right?
Yeah.
Um, but the key thing for them was finding that pattern of this high delta, that says that this is the good one. You know
Yeah.
what I mean? But so then I was going to say the second thing is more broadly than just this very specific application where you need to identify the answer tokens. So then Warren showed us this repo, and so we can talk about the paper some more, the repo some more. But then it's just this general idea of let's look at patterns in the probabilities, in the comparison of the probability of this one, that one, the attentions, can we find hints in those patterns that tell us whether the LLM is on the right track or not?
I think I'm okay. Is somebody mentioned somebody's breaking up?
I don't
It was
think
an
so.
echo.
Oh, I thought I heard something.
I heard an echo building up. That happens when a geometry changes in microphones.
Gotcha. Yeah, I think that all basically sounds correct to me as far as I can understand. That the this is perhaps interesting here, where they have a couple of different methodologies, but I think alternatively. Oh yeah, and then you can actually the other kind of interesting
Hey,
thing.
Warren,
Yeah,
is it possible to remove that left tab that you have on the right screen? Oh, sorry, the
remove
left panel.
this.
Y-
Oh, or remove this, or oh, is this it? Did I remove the correct thing?
That's also better.
Okay, cool,
And
cool.
yes,
Nice.
Okay.
Very readable.
we don't see any text anymore. Yeah, okay,
I
now
see
it's
things.
Hmm. Do we see
popped up
text? Do
just
we
now.
not see
Yeah,
text?
okay. Maybe it's some slowness on my
QA
side, but
required.
I see it now.
Yeah,
Okay.
yeah, we see the paper. I think Dev, maybe your connection's slow.
My connection is
Yeah.
also often not good, so between the
No,
two of
no,
them,
yours
perhaps.
yours
Okay.
looks fine, Warren.
Okay. But yeah, the thought that can sampling achieve a similar effect and unveil the chain of thought reasoning path. So I think like your observation there is correct in that yes, this metric is what we're looking for, but what we're actually looking for is the thing that this metric is indicating, which is that that chain of thought has been performed during decoding. And then they mentioned self-consistency, which I don't remember off the top of my head. There might be something in the library somewhere, but I presume that it's just like another prompting method, or it sounds like another decoding method actually.
Yeah, I can help with that. So self-consistency is really simple. It's just I don't remember exactly what you do with like temperature or whatever, but basically you just pick how many times you're going to generate and you do voting. So if you say, blah 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 is this word problem, how many apples does Sally have, and you just complete it 7 times, and 4 times it said she has 12 apples, and then 3 times it had different answers, then you're going to go with 12, the majority vote. So it's pretty straightforward.
Gotcha. And then, yeah, I see. I have, in contrast, chain of thought decoding works by explicitly encouraging diversity at the first decoding step, which I'm like trying to make sure that I make sense of, because to me it's like, or like, does this mean that you are essentially having to do a large amount of extra decoding here? Because you'll need for each sequence to be able to get this value. So as such, then you would have to be like effectively like actually running all the way down these token predictions in order to get that value, or are you able to get it in advance so you can figure out which of the K paths you should go down?
It is going to be more expensive because if you say I'm going to do 10 paths, then it's 10 times the cost of if you just did normal decoding, right? Once again, though, this works because you have a very known question and then you're decoding for one answer, right? You're not repeating this every token. You just say, I know that my question is, here's this word problem. Sally bought some apples, gave some apples away, bought some more apples. How many apples does Sally have? You choose your 10 top probable tokens right then and there. And then for each one of those 10, you just do normal greedy decoding from there until you get to end of sequence. Okay. So this way it's very limited to something where you know exactly when you're you kind of know when you're starting decoding, but where you really know that you only care about branching at that very first token.
Yeah, my first thought there was like, isn't that basically just asking the same question to the model 10 times and basically just getting 10 responses? But I guess it is.
Right. That's why they compared it with consistency, because consistency, where you just said majority voting out of 10 would have a similar cost. Okay. But they're saying that their metric for which one of the 10 you choose is different from majority voting. That it's possible to have the majority answers be wrong, and that the best answer maybe only appeared in 1 or 2 of the 10.
Indeed.
Does that make sense?
So not to derail the discussion here, but with self-consistency, do you play around with the temperature so that you have more variety?
I don't remember how they do the repeats. I'm guessing yes. It's just whatever you're normally doing. You do, nucleus sampling, top case sampling, whatever your normal strategy is, and then you just do voting. So I don't know if it's true. I'm just simply saying in the paper they claim that, hey, here's an example where we looked at 10 paths and we got this one answer 4 times and it was the wrong answer, and this right answer only appeared twice.
Yeah,
Right. And even if you don't change the temperature, there is some path somewhere down there where there will be some diversity. So even if it's not the very first one, and you don't necessarily have to change the temperature every time.
And I think, this seems to be relevant to me, where that they're mentioning, since we already decode the top K paths, one natural extension is to aggregate the answers over all those paths, similar to self-consistency, but without the use of prompts. The rationale behind this aggregation is to mitigate sensitivity to small differences in the model's logits, particularly when relying solely on the path with the maximum delta. I really want a way to shortcut this delta if I could, but I don't see a way to get around it. If you need to grab all these paths.
So Warren, what is the delta measuring? The diversity, or?
I believe when relying on this solely on the path with the maximum delta, and from my understanding, the path with the maximum delta will be if we take at step 0, so we have 5 I, we, u, and then we have the confidence metric of all of those. Well, you could just pick the most confident one, but then you're doing self-consistency. We don't do that. We actually decode all of them, but then we pick the one that has a high confidence metric at the very end. And then you take the delta between those two and you say that's the right answer, is my understanding so far. But I could be, I'm a little fuzzy on it, so. Let's see. Let's see. So we have a couple of experiments, and this is largely, so we have GSM-8K, we have multi-arithmetic, then we have common sense reasoning, which is a year parity, so you'll notice that all of these will have very clear right answers, and they will all be numbers. Or some of it looks like even or odd, so which effectively is a Boolean, right? What I'd like to exactly figure out is there a way that they can do this on things that have a less obvious right answer. Let's see. Which I'm presuming, my thought being that since what they're doing is calculating the delta, then they need to kind of know in advance which of those tokens is going to be a like high probability one. But then that, I feel like that should translate out if all you're actually caring about is that delta, and you're saying this includes a chain of thought during decode, so it's probably pretty likely. As long as you are just doing the full decode and then you are sampling this confidence metric. So as long as you can compute that confidence metric on something that is like a more fuzzy thing than GSM 8K or a math question, then I think you should still be able to do this. Or at least that's my intuition, so to speak. We present popular decoding baselines on Mistral 7B, including temperature sampling, top K sampling, and nucleus and beam. So we have kind of the baseline. We take the model, we will give it a K of 10, we'll do a P of 0.9, we'll do a beam of 10, we'll do temp of 0.7, and we're just going to greedy decode all of them. And then we have a pretty significant increase on GSM 8K at least, which is kind of cool. Let's see. And it's some of the decoding methods even hurt model reasoning, as far as I'm seeing.
Warren, do you know what the GSM 8K is? What is the that?
Off the top of my head, I don't remember exactly, but I remember it's some kind of like academic benchmark. So it is like a lot of reasoning and math type of questions.
So it is the grade standard
Yeah.
math up to 8th grade or something.
Yeah.
Like that.
Okay, great.
Yeah, which
and
is
it more reasoning focus, Dave, or is it also like information, knowledge?
So there is reasoning involved to get to the answer,
Okay.
but the complexity is limited to middle school level, up to middle school.
Okay.
which is, although the nice thing about decoding and similarly with the sampling thing is that it works with anything, right? Because like everything's going to have to decode. So you can take a Palm 2, you can take a Mistral, you can take a Gemma, and if you're willing to dump the extra compute into doing this chain of thought decoding, you will, or you presumably, if the theory holds across other, like if the delta is still valuable, then you can throw it at anything and it should bump it up a couple of points, so which is at least useful. And seems to scale apparently, which is good. Your parity significantly boosts the performance by recovering the COT paths. I'm particularly interested in, I don't think I have my plugin. Do I have my plugin? I don't think so. The what I'm wondering is once we get to the limitations section, that's really what I want to know, is partially closes the reasoning gap between pre-trained and instruction-tuned models without using any supervised data is interesting. COT decoding enables a pre-trained model to achieve similar performance of an instruction-tuned model, which I guess makes sense because if what that delta is doing is actually telling you there is a chain of thought here, then it doesn't really matter if you have, like if you've tuned for a particular type of response, because you are explicitly searching for that exact type of response, provided that this delta continues to be useful. Let's see, partially achieved by modifying the decoding procedure. Can further improve the instruction tuned model. Okay, so does this make it comparable? Similar, okay. So if we are already instruction tuned though, then presumably we'll be more inclined to do COT. So to me, it would make sense that if you're more inclined, then it's going to be more likely, but you're still, as far as I understand, you're still decoding the same number of things. So, okay. So you're still spending the same amount of compute, but presumably the high delta includes a chain of thought answers are better, which makes sense because you are instruction tuned and you are instructing it to do this one of these things. So those chain of thought should be more consistent. Occasionally persists in attempting to directly address a question.
Warren, one other question.
Mm-hmm.
Do they compare like the same model using chain of thought decoding versus the same model using chain of thought prompting?
They don't, or I believe there's a section, or I remember a section that mentions this technique is essentially prompting agnostic, because what we're doing is we're decoding multiple paths, and we are
Right.
always going to do that regardless of how you prompt it. So if, and then I believe it says you do get performance gains, or it might have either been in the like extensions section that like you should go explore this. But either they found it or they think it's probably pretty likely that you can combine this with a prompting strategy and get like this like combined increase. Let's
Okay.
often.
Because
Hey,
I guess what I'm wondering is if so somewhere in here the path exists for this chain of thought response.
Mhm.
That exists in the language model already, and they have a decoding mechanism that kind of helps to uncover that particular path. Um, does a chain of thought prompting simply change the distribution so that that hidden path is more likely to be selected in, a greedy or a top K
Hmm.
type of decoding? In other words, does the language model, um, it already contains the chain of thought, whether you get it out through this type of decoding or through prompting, the end result is going to be kind of equivalent because that sequence, that path, is the same path. You just uncovered it differently.
Right. I think I see what you're saying. I don't recall. They may have that answer. I don't think they do in this paper, but it would. Like to me, it would. I feel like there's a way to test that, right? Where you could, because like the way you kick this off is you take your top K paths, write it like at the I believe it's the very first token. So if you do that a few times with your chain of thought prompt and you consistently get highest delta is a continuation of kind of this chain of thought, and then you run the same prompt back and you don't get or if you just consistently get that same output, maybe. I don't know. Yeah, no, I think that maybe I don't think that's correct, actually. I think because yeah, I think that would need to be tested. My hunch is maybe that it would, because you can give a chain of thought prompt, and then, but like what exactly that is kind of relative as well. Like you can say like think step by step, or you can say like take your time, take a deep breath. I'm going to tip you $200. Blah blah blah. So you can still you can in the prompt step you can do various tweaking there as well. So if what you're doing is selecting the correct continuation of the prompt, then I would think that would just sort of be an extra layer of like I also included a tip $200, except I did it with like math and stuff. But that is wild conjecture. I mean intuition.
hey, Warren, I have a couple of questions. So, the previous chart that you had that had Palm 2, which is, if I'm not mistaken, a very big model from Google. Is this paper from Google?
I don't think that this one is. Is it? Oh, it is. Yeah, it's DeepMind paper.
Okay, which makes sense, yeah,
Mm-hmm.
because to have access to these kinds of experiments, especially with a model like Palm 2.
Yeah.
Uh, and now I'm trying to recollect my second question. My chain of thought is broken.
Oh no. What's the
All
delta,
right,
man?
huge. Uh, ah, so if we stay on this chart, then figure four.
Hmm.
There you go. Yeah, figure four. Uh, yes. So greedy does get better with instruction tuned, and COT decoding beats greedy instruction tuned as well, which is greedy is, let's assume, the default behavior, right?
Yes. Yeah.
Okay, so all they needed to do was that the default model. Uh, and then instruction tune for a specific task, in this case, GSM 8K, is already tuned for, even if it gives one final answer without the chain of thought or whatever the process is, internally it may be doing all of that. But with COT decoding, you're saying that, as Roger was saying earlier, that maybe it is eliciting or not explicitly but implicitly going through the same kind of prompts internally for the instruction tuned and then dumping the final answer. But looking at your entropy outcomes is much more powerful uh, than a model that is not thinking and reviewing along the way.
I think
And
so.
that's
Yeah.
so powerful statement if you think about it. Instruction tuned is 67, 68%, and COT decoding for instruction tuned beats it by 15%.
Yeah. No, that's a quite a significant jump, which is, and then on the year parity, which is that kind of uh, uh, like binary, like yes, no, did you get the right answer kind of thing. We have like the greedy decoding is just awful, and then we can go up to almost 100% with COT, which is kind of interesting.
So
Um,
what would be really interesting would be that instead of using, see, this is all inference time. So once the model is out there, Palm 2 has a base, like the extra small is 9, whatever that measure is, right? The extra small on, no, no, on the same figure.
hmm.
Yeah, 9 and 17.7, right?
Oh,
So
okay,
if
yeah.
we have some open source model, let's say a 3 billion Llama or Ministral or any of those which claim pretty good performances, and I don't know where the GSM 8K outcomes are, one could potentially keep on trying COT decoding to see, well, I will increase, as Ted mentioned at the beginning of this meeting, it is exploding only in the first uh, token prediction. After that, it is greedy. Well, you can maybe figure out, maybe there's a path where you can be more, expand your tree further and maybe get better results with open source, which I don't know. I don't know if it will ever reach those big numbers, but worth trying some experiments with open source, which of course these people would not, I would forget, DeepMind.
Yes, well, funny you should mention because that's essentially what those other repos are doing. Whereas this is selecting from the initial top K, like picking a metric and saying this is the right one, go for it, and they're getting this jump. What the repos are doing is they are during like during inference time, they are adaptively changing the sampler either every few tokens or every or there is an opportunity to modify the sampler at any given next token prediction in order to find a better path if you're steering down the wrong road essentially. And
Right. And yes, go ahead, Gordon. Sorry.
yeah, and they are we haven't ran any benchmarks yet, although hopefully next couple of days. But the results, just like in terms of vibe checks, have been subjectively pretty impressive. Like the the sub 1B model in the collab that I showed earlier gives a like fairly coherent with math response to like a question about quantum dynamics, and it can do interestingly the same model without any optimization can also answer which number is larger, 9.9 or 9.11, correctly, but the reasoning it gives is just like it's nonsense. It's just like random words essentially. Whereas the and I presume like if I reran it, I might be able to do some comparisons, but like the reasoning steps remain like fairly consistent, even with like a sub 1B model, which is kind of crazy to me.
And if I'm allowed to continue on this path
Yeah.
of unit mode. So one of the things that one of the recent papers found out, and I have to dig up which paper it was, that when they, maybe it was that Apple paper, that when they added a little bit of nonsensical or irrelevant information in the prompt related to any of those GSM-8K or other kind of math problems, many models tend to fail miserably. O1 and maybe to some extent so Sonnet did okay, but they also degraded in performance, but not as much, like maybe 2% or so. And then their numbers are very high. They're like 90+% in some of the good benchmarks. But then when they, the thing that I'm trying to get to is the reasoning part that you mentioned about the outcome and the answer explanation. Maybe that is messed up because those models may not inherently have capability to uh, maybe reasoning is not the right thing, but if, and I'm combining two different aspects here, but trying to get to the common ground here, which is that the smaller models may be limited in terms of their reasoning abilities to begin with. So even if you go through COT path as much as possible, the answer that you got for 9.9 and 9.11 may potentially be data leak, which is what the other paper was also trying to say, that even though you see good numbers in the benchmarks, but as soon as you make a little change, the performance drops dramatically, and those little changes just not an irrelevant sentence in the whole problem statement, and they just go haywire, which is kind of indicates some kind of lack of generalization. And the point that I'm trying to make here is that while I'm hoping that we'll see a similar kind of gap between 3D and COT decoding for almost uh, all the models, whether sub B or whatever 3D or whatever it is. But at the end of the day, it depends on the training, pre-training that happened on those models, and if there was already some data leak or some other things also, which may impact the difference also.
Yeah, I would. I think I would largely, essentially agree. I think I remember the paper you're talking about, where if you add, like it was O1 Mini especially that just completely fell apart. Was the article I think I saw? I don't think I read it, but I think that seems largely correct to me. The thing that's coming to mind is we actually like tested that, maybe inadvertently tested when we or somebody earlier today was testing the Nemotron, the new 3.1 from NVIDIA, and it was a like complex, like a complex-ish, like Sally has X hundred apples, and then at the end of the week loses some amount, and then picks some more, and then plants the seeds, and some of them end up growing. And also some of them are are generally misshapen. Like there was this little extra thing at the end that was like a red herring essentially to try and like bait the model into it, and it would handle that fairly consistently. But this was the Nemotron, the new Nemotron 70B. So it presumably has like that sort of reasoning capability kind of already ready to go, so it might not be as vulnerable to whatever technique, or it just might have been that there hadn't been enough noise injection or not enough runs to really like make anything meaningful there, because we're still largely pre-benchmark with the other techniques. Let's see.
At brings to mind for me a kind of an interesting experiment would be to see how do prompts that precede the sequence, how do they change the distribution of token probabilities?
Mm-hmm.
So, if you can imagine if you know the chain of thought that you're looking for, that sequence, and you should be able to say determine what is the probability along the way for that sequence, and then observe how that changes if you give a chain of thought prompt, or see if it changes adversely if you put in some sort of um, red herring type of component in the prompt as well.
Yeah, or yeah, I had that thought earlier that like because you have to pay attention to all of the tokens and you're doing backprop anyway, the like sure you have like if you presume the totality of the sequence, then you have a part in the middle when you started feeding the prompt in that is going to like you're going to get that top K and presumably you get the performance increase, but like you still have a full sequence worth of variables to like be concerned with, and then you can as it continues going, that that like combinatorial space just gets much larger. I think somebody is doing something in the group chat with like with regards to the attention heads specifically, and there might have actually been something in the repo already. I think it was like measuring entropy on some of the attention heads as well. So if we end up getting to that, then we can take a look and see. Okay, well, yeah, and here you have it, I think, right? The presence of the correct, let's see, intrinsic reasoning abilities. Okay, so that's exactly what you were referencing earlier, right? It's not showing me people's names for some reason. But is the reasoning even in there in the first place, was what we were asking, right? Enables a more truthful assessment. We show that they possess reasoning capabilities for grade school math, and now we're going to vary the levels of the task to gain a more comprehensive understanding. Okay, sure. For each task, we produce 100 examples of each difficulty level except Web of Lies. We use the existing data set from Suzgun. We also include 2 natural language-based but synthetic tasks from Big Bench, Sports Understanding, and Object Counting to probe a model's intrinsic capabilities in solving synthetic tasks. Let's see. So varies depending on the test difficulty levels, and then we still see like some amount of performance change here. And the presence of the path depends on the task difficulty and correlates with task prominence in the pre-training distribution. The results in Table 6 on Palm 2 show that despite COT decoding helps elicit better reasoning across almost all tasks, the gains vary significantly depending on the task and difficulty level. The simpler it is, the better chance that a correct reasoning path can be found.
Quick question.
Mm-hmm.
So in table 6, the numbers, it says reasoning ability. What do those numbers mean?
That is a good question. Let's see. It looks like they don't specify as far as I can see. Oh, wait. Well, if for each task we produce 100 examples, so presumably like you got 94 of them right, you got 57 of them right, maybe?
Okay.
But they don't explicitly spell that out as far as I can tell. Can generate correct COT paths when the solution involves at most 1 or 2 step knowledge manipulation. Starts to struggle when it becomes 3 or more. Okay, so this is top K. Effective K reasoning accuracy with regard to scales and test difficulty. ITL. So model size here, and then accuracy, and then top K tokens for decoding paths. So if the path is 10 tokens long, then something, or number of tokens maybe. Let me just pop back down
And
here.
IT is
Good question. I'm assuming that's like even larger, but I don't really know exactly
because it
where.
saturates very quickly.
Mhm.
Let's see.
IT is instruction tuned.
Oh yeah. Yep.
Okay, yeah.
Let's see. Phenomenon suggests that the correct COT paths become harder to find when the task becomes more synthetic. What's the definition of synthetic here? I wonder. Mirrors the finding in McCoy. Is this going to give me a title? Embers of autoregression, understanding large language models through the problem they are trained to solve. Interesting. Might have to grab that one. Where the authors show highly influenced by the distribution they have been trained on. Seems kind of obvious, right? Presumably, if you train it on a distribution, then it will predict from the distribution.
It'll do very well on that prediction.
Yeah, presumably.
Shocking.
But does that what does that mean though? The training distribution. I mean, does it mean that there's chain of thought in the training material?
The correct COPD paths when the task becomes more synthetic. I really wish they defined synthetic because that would be the answer, right? One or two step knowledge manipulation. Highly influenced by the distribution they have been trained on. Tough to say, I think. Only improves only for larger cases. Task complexity increases higher D's and L's. Let's see. Let's read a little ahead and see if we get anything. Over these synthetic tasks, coin flip, web of lies can generate them that simulate the process, but can easily lose track of the states, especially models' intrinsic vulnerability. It tends to perform calculations from left to right in the decoding paths rather than following the correct mathematical order. Interesting, because at least because I don't know if you guys saw the paper before, but there's a paper that's sort of like stuck in my mind repeatedly that when you're doing chain of thought, at least at the prompt level, the reasoning steps don't have to be correct in order for performance to increase. They just need to be there. So like, yes, that might improve if they were correct, but it also might not. So I guess like not a strong claim here in my opinion, but existing COT prompts on Big Bench hard play a larger teaching role in guiding the model to solve such tasks, and in most cases the model just mimics the patterns in the COT prompts to generate the correct response. Big Bench, whether chain of thought can solve them. E.g., the few shot COT prompts teach the model to perform explicit state tracking in each step for Web of Lies. I think I'm a little fuzzy here just because I don't know what a Web of Lies exactly is, and then like, okay, where are these, like, how are you few shotting? Like, does Big Bench default you to prompts that include a COT? I don't really know. So, few shot COT prompting constrains the model to follow an artificial strategy curated through human knowledge and intervention.
But I think this is probably the lines of what Rod was asking earlier. Very much close to that appeal, that it seems to be uh, mimicking the patterns in the prompts to get the correct response. And I think that Roger to uh, explore earlier. Is it right, Roger?
Um, yeah, I think that was the question I was asking anyhow, yeah.
I think what's occurring to me here is that few shot COT prompting constrains the model to follow artificial strategy curated through human knowledge. The difference here is that since it's on the decoder step and all you're doing is looking for probabilities, there's no like potential contamination from a human prompt, right? That's something that's jumping out at me. And then we have the combining section. Easily combined, even larger reasoning gains over multiple language models. Let's take a look at table 7. I want to see this. Greedy, self-consistency without COT, COT decoding max path, COT decoding ag path. Did they mention exact? I feel like they mentioned that at some point, but I don't remember exactly what it is. Can I control F aggregated? Aggregates. Self-consistency aggregates. Okay, we already decode is to aggregate those. Okay, so this is just like a other thing that we could do. Combining. Okay, so ag path and then max path. COT. So this is just like we're not doing any extra processing to this collection of deltas. We're just picking the highest one, and this one is like we're attempting to smooth out like the weird little logit outliers, presumably. And then we have with prompting, so 0-shot COT, self-consistency with 0-shot COT, which is the biggest jump. COT decoding max with 0-shot COT, COT decoding ag with 0-shot COT. So what about 10-shot COT with COT decoding ag path and the entropy variable sampler? How good could we do? That's what I'm curious about. Let's see.
Okay. I was going to inject Warren if,
Mm-hmm.
and just at the time, 7:40. The notebook that you had looked like it had a number of interesting graphs on that. Is that have you dived through that enough to kind of guide us through it, or?
I can take I have that notebook, not specifically, but I think it's basically just the same thing with the graphs. Let me see if I can find it here. Pull that there, and then this guy. Yeah, and let's see. This is usually So I guess the with the notebooks, the two of primary interest, and I think probably the most interesting one. So I guess for anybody that missed it last week, there's like a technique involving measuring entropy and varentropy during the sampling process that's like similar and possibly complementary to COT decoding, and I think that's actually something we're currently exploring. And then this notebook is small LM, which is the using halfly tuned thresholds of the original notebook from a couple of people for small LM, and then for Llama 1B, and then tokenizer params have been modified to support small LM 330M instead. So we have like a Llama initialization, I think, but we're doing it on the small LM, which I don't. That was weird to me that they did that, but I think did I run this one specifically earlier? Let me scroll down and double check. Yeah, I did. Okay. But the interesting part here, so I don't think there's anything particularly unusual, other than like we're initializing Llama 1B params. And with this other model, download the weights obviously is that. I think that is normal as well. And then there has been, I think somebody was talking about weights initialization, but I don't think anybody did anything, at least not in this repo. Loading the weights seems normal. And then tokenizer. So we had to modify this, but I don't think it's just to optimize, just to try and make it work. The following constants remain unchanged. Encode and decode. So we're just doing the raw like self-model decode. We're doing the normal encoding. And then standard tokenization. We have a regular old KV cache. And then the attention stats. So this is where it starts to get interesting, because you'll notice that we have entropy and var entropy being measured here. And I think we were looking for that last week, exactly how that gets calculated, but it is, I think there's just an entropy score that you can either like relatively easily calculate, or like maybe it's a torch built in, I'm not sure. But yeah, there's like a BSZ, a number of layers, and a number of heads. And I don't recall exactly what BSZ stands for. But you have these like these extra little stats that you're keeping track of, basically, and updating them. You have your like rotary embeddings, where attention is, I think, fairly normal. Let me see. I think this one is just regular attention stuff. Yeah, default mask value, feed forward, transformer, and then sampler config is where it starts to get interesting. BSC is tokens.shape. So sampler config. So this one is the adaptive focus sampler. So I think this is actually even more involved than the other one. We have a bunch of sort of like, I think mostly arbitrarily set thresholds. As far as my understanding goes, it's just sort of we threw, vibe checked it and threw it in there. But we have a whole bunch of extra stuff that we're measuring, and then what we're going to do is we are going to keep track of all of that in order. So this is like the sampler config, and it's just like, okay, like we have a bunch of extra things we're keeping track of. We might cross-reference like low logits entropy with medium, with high, var entropy, attention var entropy, agreement, interaction, and some of these are sort of like custom computed values. They just sort of like took a few arbitrary numbers they could find lying around and then presumed that will be agreement. I think there's like some method to the madness, but there is a lot of madness. So
and it feels like kind of a data exploration.
Very much so, yeah. And I think that's kind of the goal, really, where it's like, okay, we think that, so this last week what we were looking at was just flowing, treading, exploring, and resampling, and then we have an adaptive here at the bottom. And then we are going to calculate the var entropy of the probability distribution using log softmax.
Mm-hmm.
Then we have a multinomial samples one token from the multinomial distribution with sorted probabilities. So we're just going to grab one token and we're going to measure those things on it. And then we are going to what I'm thinking here is if we're just going to sample one token, could we sample like one of top K tokens here maybe, or something like that? And then we have our min P, top K, and top P sampling options. And then we're going to calculate all those metrics that we put together before. And then we're going to sample after we've done all of this extra math here. And then these sort of different quadrants of like low, low, high, low, low, high, high, high. And we are going to change our return our sampler state. So we've defined a sampler state of some kind, which is flowing, which I think was up here, right? And then, okay, so that's probably defined somewhere. But the main thing that we're getting is we are going to ask clarifying questions here, insert a clarifying question token if not already present. And then if we've just asked a question, we are going to crank up the temperature a little bit and see if we can search around and find where we're supposed to go. Low entropy, high var entropy, we're exploring forks in the path, so what we're going to do is adjust the temperature, adjust the top K, and then we are going to sample logits, and then get, looks like a temperature adjustment of 1.5 times, so we're going to crank it up as far as we can go. Or not as far as we can go, but like a bunch. And then high entropy.
Warren, can
Yeah.
I ask a super quick question?
Yeah.
In these 4 different options, it looks to me like they're still only picking one next token, right? They're just changing around the conditions, how they do pick the one.
Mm-hmm.
So,
yeah, that tracks to me, I think.
okay. Yeah, so like, I can see that if you think that the LLM is lost, right? It's not sure what to say, it's just lost. You really don't have much to lose by whatever, inserting a clarifying question, changing the temperature. You can do anything because you think that your answer, if you don't do anything, is going to be garbage.
Yep.
Right? But it does seem like, given only one forward path, not sure how much that's going to help.
Let's see.
Does that make sense?
I think in order to my thought with if they're grabbing the one token to determine, the question would be like, do they, for any given sequence length, do they always only grab one token and then make the adjustment there? And I think the answer to that is no, because if we go down to the bottom here and skip ahead a little bit, we will see that over here we have we've predicted 8 tokens, and then we've triggered 8. We're gonna go into this like exploring mode, and then over here we've sampled 40, and on token 43 we're gonna go into exploring mode, and we're gonna check our entropy and var entropy again. It looks like it's back in range, so we're gonna go back to normal. So my thought is that is only defined once in that, like, sample is only defined once in the code, but presumably there's a loop there of some kind. And then, as you can see, we have a few.
No. I get. Sorry, I maybe wasn't clear. Yeah.
No worries.
So I get that you're making this decision each token, repeatedly making this decision. But what I'm saying is, if you think the LLM has lost its way, like if you look at those charts where it wasn't the lost, but it was the exploring paths thing.
Yeah.
You're not really exploring paths plural. You're just saying, I'm willing to accept not the most probable token, because I don't know that we're on the right path anyway, so it could get worse or it could get better. I'm hoping it randomly gets better, but we're just in a lousy direction, so what do I have to lose? You know what I'm saying?
Yeah.
It's not quite like the paper or other things where you do a search and you have multiple options to choose from. That's all I was just trying to clarify. It seems like nowhere do we see where it's creating a list and keeping track of options. It's just doing one at a time.
Yes, yeah, I believe you are correct there. Thus far, yeah, there isn't we're not going to kick off a new beam or like try to crawl down a new path of MCTS because we're just we're throwing it all in the garbage or something. I think it's basically like, are we lost? How lost are we? Are we kind of on the right track, but it seems like there's a lot of right tracks? Or are we like not lost at all and we are definitely, like, there is not a lot of right tracks. We are on the right one, and we're gonna like just check in there, and we're gonna keep like bouncing around to see, because presumably, because like once you insert this next token, like somebody was mentioning earlier, it's like, okay, now the entire distribution has changed from what it theoretically otherwise might be, right? And then but I believe, speaking of, in the main repo, I think there is a section where somebody did try to implement MCTS on top of this as well. And I don't know if they're using the entropy sampling to try and kick that off, or if they're just like, here is a good way to implement MCTS in like the context of an LLM. Let's do that and also do this.
Is that one of the branches in this repository, the Entropix repository?
Yeah, we have mcts.py, and this is this in main? I think okay, so main has this, yeah. So we have an MCTS search. Is it in the normal range? Simulate the path. We're going to search, select the initial candidates. If none of it leads to the normal range, return the first candidate. Let's see, simulate path. So we're going to do transformer weights, model params. And and then we're also, during the MCTS, we're also going to try to calculate this var entropy, at least of the softmax. So we're going to go like entropy on logits. It doesn't look like we're doing entropy on attention here, as far as I can see. So it looks like we're doing some, we are sampling entropy to determine like when we are going to start searching, and then is normal range, return token true, return self next token squeeze, current position depth +1. What I was wondering is, I'm trying to remember what I was wondering, but I might have forgotten it already. Calculate var entropy over the softmax. Yeah, it's gone. I think the other branch that's interesting. Do we usually like wrap it around like 8-ish? Is that kind of where we're targeting here?
Yeah.
Okay.
Yeah.
Let me see if I can figure out just the last couple of minutes here and figure out what Frog is doing, because Frog is doing something interesting, and I don't know exactly what it is. One of the things he's doing is including the best color palette with the sampler, and
They
then
have good colors.
absolutely get color for metric. Oh, is he actually coloring based on metric? I think maybe I know somebody did that. Yeah. So logits entropy, logits var entropy, and his sampler looks like a lot different from the other one as far as I can tell. Agreement interaction strength, and we are going to do the same sample one token. We're going to sample it. We're going to min p top k top p. Calculate. I see a mean attention that I think is different. How many source graph? How many of these are? Find references. Okay, so it's just his one. GMP mean var entropies, and then sampling hyperparameters. Again, seems somewhat arbitrary, but much lower, I think, from what I'm remembering. Offsets and coefficients for adjusting sampling parameters. Adaptive oh yeah, so I think he was trying to do, I think these are hard coded in the main branch. And his thing that he was doing was adaptive sampling of some kind. Which, I'm going to see if there's something in here that will indicate if that is the case. But I guess while I scroll, if we're getting into the last couple minutes here, I should probably is there any thoughts, comments, questions, other things that people wanted to say before we're hitting time? I suppose.
I think as I was looking at, I was playing with, not specifically this repository, but playing with the ideas. The someone made a comment last time. It may have been in the chat. Maybe Sally said it out loud. That it's kind of reminds you of the Monte Carlo stuff we saw with the AlphaGo, AlphaZero, all that, but applied to language model decoding. Um, and if I'm understanding correctly, these are just kind of different ways of defining what are the branches that you might want to explore. And then, Ted, you had said earlier, you need kind of a way to place a value on a particular point on a particular branch. It'd be interesting if there was a framework that kind of placed it, does all the exploration and just allows you to plug in value functions. What were the two? It was a value function and a, do you remember?
Well,
AlphaFold had.
I mean, for a search, you just need one value function, and then you got to decide how much search you're going to do. But Warren, you mentioned that one person was actually looking at hooking up Monte Carlo tree search. The thing is, Monte Carlo tree search is very expensive comparatively.
Yeah.
And so most of this stuff, that was why I asked the question. They're not really doing a search. They're really just changing the way they predict the next token. So if the state says that the model is very sure what it's doing, so in other words, the next token probability is really high and all the variance is super low, so it's just like, I am 90% sure of the next token, and I'm going to be 90% on the one after that and 90% on the one after that. That's when you don't want to mess with anything. You want to just let it keep going, right? And if it says like, well, my top probable token is 1%, and there's 500 tokens that are all equal, close to equal, then that's when maybe you want to mix things up. But they're not actually keeping track of separate branches. So for me, it seems like it's an interesting idea, but I feel like there's a really heavy glass ceiling on how much you can improve things if you don't actually do a search, if you really only just have one path forward.
Yeah, no, I think that's and which is why combining the two approaches might be kind of interesting. So if you do COT decoding, and then while you're doing those top K decodes, you also try to check entropy on each of the top K potential paths, then I wonder if that would work, because since what you're doing is calculating delta, you might get a better delta, and what the delta is telling you is that there is a chain of thought here, and we're assuming that this decoding of chain of thought is better. But this, if we're moving all the dials while we're generating that chain of thought, so presumably that should work then, I think, because you will have maybe the same deltas or whatever, but as you have been doing that decode to select from, if this sampling method is making that chain of thought more coherent by kind of keeping it in bound of we'll randomize when you're not sure, and then we'll lock you in when you are, kind of thing, then presumably you should get a better chain of reasoning, I think, right?
Yeah, that makes sense. And worst case scenario, maybe you tweak the way you calculate the delta a little bit just to make sure you're not messing it up with this stuff.
Yeah. I think that definitely checks out to me, and it's all, especially because it's, and it could be nice to, if I'm an end user of a model, right? I might be willing sometimes to spend 10 times the compute on this answer, but I might just want a little bump because I think it's going to get is going to be a little tough for it to navigate, but I think it can do it. Whereas, I want it to think for like an hour before it starts, if in some other situations, right? So I think either or both could be useful, if I had a dial to flip between the two.
So Ted, was it this even? Are you saying even that original, the first paper we were covering, chain of thought reasoning without prompting, those are not exploring multiple paths. It's just a single path that they're exploring differently.
No, the paper does.
Mm-hmm.
At the first token, they consider
Oh,
however many, and
oh,
then
oh,
only
okay,
do greedy from there, so that they're capping the cost based on
right.
how many of the at the first. But they're guaranteed to get variety
Yeah, yeah.
at that first step
And just
because
that one.
they're not doing sampling. They're literally saying, if K is 10, take the 10 most likely next tokens. So they're guaranteed to all be different,
Yeah. Okay.
right? Which
Whereas
is
this,
kind of different from when you see people like doing, random sampling and multiple, like the consistency, multiple iterations. You know,
so, but you're thinking this Entropics repository is only doing a single kind of beam.
yeah,
Mm-hmm.
I should
yeah.
use beam.
Except for where Warren said somebody's looking at inserting, a tree search, but
Yep.
Yeah.
otherwise everything is really just at every token. Do you just keep decoding like normal because you think it's on the right track, or do you try and mix things up?
Yeah, the other to me, like, Entropic specifically is, like, it's having some interesting like performance increases, but moreover, it's mostly pointing out to me that like the sampling and inference step and things like decoding are like generally underexplored, because we hard coded in all of these like all of these parameters. We just pick numbers. So if we could find a way to like sweep these hyperparameters while we're generating, then that could be another lever to pull. And then we could throw that on top of the MCTS when we want to spend a ton of compute. And yeah, moreover, it's just like it's kind of a similar thing to the cans, right? Where it's like, yeah, this thing is cool, but moreover, it's that this thing was done here. That is the particularly interesting part, because hopefully there will be more interesting things to do.
So it sounds like this is an area where there's a lot of active exploration, a lot of active work going on right now.
Mm-hmm. Yeah.
Is that right? So we're probably getting close to time here, but it would be nice to come back and revisit this in another, couple months or something like that, and see what progress has been made.
Yeah,
'Cause, yeah, it does
absolutely.
have that feeling, like you said, it's like it feels like it's underexplored, or certainly from my perspective, I haven't heard about it that much, and so it's really interesting.
Yeah, it's definitely just starting to kind of like hit the mainstream zeitgeist and get to the AI YouTubers and such. So I'm presuming there will be a lot more people iterating on it. Because last time I looked, there was only like 2 other repos on GitHub, and I'm sure there's like hundreds by now. And yeah, the sort of like core team of people who got interested in it in the first place are all like making some pretty solid strides on their own. So it's definitely should be pretty cool whatever comes out of it, I think.
Cool.
Yeah, I think generally it is a little bit underexplored, but now, of course, there's so much hype around LLMs. Lots of people are, turning over every stone, right?
Mm-hmm.
I remember it was probably over a year ago, down here in San Diego. Um, we had a speaker who was a grad student, and basically, he was looking into something like if you had a weaker LLM and a stronger LLM, would comparing the two of their token predictions actually help teach you something? And so basically, by running it over a bunch of examples, they found some examples where the most probable token was one thing, but the token that had the biggest difference between the strong and the weak model was like the second most likely token. And so basically by goosing the numbers for each token based on how much better it was than the weak model would sometimes cause things to shuffle in terms of what's the most likely, what's not the most, what's second, what's third, what's fourth. Does that make sense? Kind of what I'm saying? And so they found that, you know, for certain things it improved the generation by slightly upward adjusting the tokens that, because basically what they're saying is that for easy things, the small and the big model will likely have very similar probabilities. And so the question is, why would the strong model have a different token prediction from the weak model? It's probably because it is in fact stronger, it knows something the other one doesn't. And so even if that's not the first token, you might want to upvote it and see if it becomes the first token. So it's another idea along these lines of what information can I have, you know, in real time, not doing a full-blown search, just one token at a time, right? Like what up, you know. So a lot of this Entropix stuff I see is data within internal to the model, just trying to see if the model's sure of what's doing or if it's kind of on, you know, unsure footing. And then now you can throw in all sorts of other options if you throw in a second smaller model and stuff like that.
Yeah. Something that has been floated was to having a secondary model doing some state tracking. I forget. I'll have to go review what it was. And the other thing that I wanted to poke around with was like, okay, we can do entropy with transformers. What can we do with either hybrid SSM transformers or full SSMs that could sort of like approximate this sort of kind of thing that we're doing here, which is a whole nother rabbit hole to fall down, I'm sure. But I just like playing with SSMs, so. Well, yeah, I guess should we wrap it up there? Do we have a plan for next week? Of